In this question, we need to sort a stack, the integers in a stack in ascending order, and the time complexity should be O(n) log n. Because in this case, we cannot use selection sort. In that case, the time complexity will be n to the power of 2. We can use merge sort to finish this problem. Normally we use merge sort to sort an array. Then we first need to cut this array into half, and every time use recursion method to cut until only one left in only one element left in the array, and then we compare every two numbers and merge them layer by layer and finish the recursion method. In this stack, we also if we use merge sort, we also cut them first and cut them into half, and we use the two actual stacks to help us to finish this merge sort. For example, this S1, there are 10 numbers in S1, and we first, if we want to cut them, we first cut them into half, then we cut them into half, and we move this half into stack 2, because this is a stack first in first out, so it will be like this. And because this is a recursion method, we still need to cut them into until only one left in this stack 1. And this is the cut we already this is the place we cut this these numbers, and then we cut from here left half in S1, and here is 3 and 1, and this place is where we cut, and we cut this, we move the 2 into S2, and now the next step is we cut these two numbers and move 3 into S2, and on here we can start compare compare these two numbers. The smaller one will move to this stack 3. 3 is smaller. Then we move 3 to stack 3, and then 5. After we finish merge, then we this is different from the array. We need to transfer these two numbers into move these two numbers into S1. So 5 is first move 5 and then move 3. Then these two numbers these two numbers are sorted and in ascending order, and then we need to compare the next pair. Compare the next pair, which are 5, 3, and 2. The smaller one will go to S3, and next one 3, next one 5. Then we move back to S1. So S1 is 5, 3, and 2 here. The next step, we need to compare the 5, 3, 2 and 3, 1, because these two numbers we haven't cut, so we still need to cut it in the recursive method. It still need to cut it in until only one left, because these two numbers are not sorted. We first need to cut them until only one left, and sort them. After these two numbers are sorted, then we can compare these three numbers and these two numbers. And then after we finish this step, it will be after we finish this cut, and we'll compare these five numbers here. With smaller, we'll move to S1. It's 1 and 2, 1, 2, 3, 3, 3, 5, and we move it back. So 5, 5, 3, 3, 2, 1 here. And we also these five numbers in stack 2 are not sorted. We first need to sort these five numbers in the recursive method. After sort these five numbers and compare these five numbers, then we can finish this merge sort. So the high level is sort a stack in ascending order, and the time complexity is O n log n. First, the step 1 is cut S1 until 1 element left, move the rest into S2. And in the next step, in this recursive method, S2 also need to be cut until one element left. Step 3, divide and conquer, and move the smaller one to S3. After sorting, move back to S1. So this is our steps to finish this merge sort. Now let's finish the code here. The first we need to the corner case. If S1 is null, or S1 is empty. Here we just need to return not empty, and only one element in S1, or one element or empty. In that case, we don't sort this stack. We just need to return and finish this function. Otherwise, we start to merge. We need to finish. Finish this function, merge sort, this recursive method. In this method, the parameters are S1, S2, and S3, and also we need to pass a length here to control which to see this length as a cut the place where how many numbers we need to sort the current step. If length equals 1, it means only one element left. We don't sort and return. Or if more than one element in S1, then we need to cut them into half. And move the rest element into S2. And then we start to recursive this method. We use recursion to cut this stack. This is a left set. We can see this stack as a left set of the array of an array. And only left length minus half left here in this stack. And we not only cut S1, we also need to cut S2 here. Because there are half numbers in S2, we also need to cut them. Then after cutting these numbers, now we start sort. We need to finish this sort here. Also, another parameter is we also need to pass how many numbers, the amount of the integers in S1 and S2. How many numbers we need to sort. This is the S1 the index here. This is S2 index here. start to sort. When they are not both not out of bound, start to compare the numbers in S1 and S2. If S1 is smaller, move S1 to the number in S1, move it to S3. Else, move S2 to S3. One plus 1 here, and in this case 2 plus 1 here. So in this we finish the sort here, but we don't know if this one out of bound or this two out of bound. So we need to, if we need to the post process here. If one is not out of bound, we move the rest element into S3, or if 2 is not out of bound, we move S2 into the rest element into S3. After we finish this, we need to move S3. The numbers in S3, move them back into S1. Okay. This is S1's length, and this half is S2's length. Okay.